Good afternoon, everyone. The good thing is with a smaller crowd is there's lots of donuts. So, yes. So if you need a sugar fix, you find yourself falling asleep, just wander on over and get some more glucose to keep you going. Okay, so I'm going to be talking about, as Francis mentioned, in essence, providing an overview of kind of the evolving relationship between Alberta's cattle industry and the changing perception in terms of what Aspen represents to that industry. And really, it's gone through quite a distinct kind of cycle. And long story short, it's gone from a foe to a friend among some individuals. And in other cases, we've figured out how we can co-manage Aspen for both livestock production and forestry production at the same time. Hence the title, Foe, Friend, or Mutual Compatibility. And you will still find individual producers that will have the foe mentality, some will have the friend mentality, and some will have the mutual compatibility attitude. And so when you leave here today, you will be able to hopefully think about what is the pervasive philosophy on private land as opposed to public land and so on. Okay, so most of us know about Aspen. I put this slide in when I gave this talk at the Society for Range Management meeting a number of years ago because I just wanted to make sure that everyone understood south of the border in the US just how widespread Aspen is. Obviously, it's a very important species across much of northern Canada, all across the boreal, and also across the Aspen parkland. So both the Aspen parkland and boreal are very important regions when we talk about Aspen and the co-management of Aspen from a livestock grazing perspective. And I want to touch on that in a little bit more detail between those two regions. If you look at the boreal forest, obviously Aspen is a major tree species within this region. And because of that, it has significant importance, both from a commercial forestry perspective, from a wildlife habitat perspective, and more recently, because livestock grazing actually is quite a ubiquitous activity. There's lots and lots of grazing leases in Alberta within the boreal mixed wood region. A lot of folks aren't familiar with that. When you have a lot of grazing leases in those areas, that means there's growing interest in trying to figure out what's the impact of cattle on Aspen regeneration and joint management with forestry activities in the area. And of course, also in the Aspen parkland, the unfortunate thing is in the parkland region, really we're dealing with a fairly diminished land base in terms of what hasn't been converted to intensive agriculture or urban industrial development. But of those land areas that remain uncultivated, which might be around 10% or so at best, a significant proportion of those landscapes is typically aspen forest. And that's going to be actually one of the initial points that I make, that ratio, the proportion of these landscapes occupied by aspen is actually increasing. So we have two very different contexts, widespread boreal forests in the north, and also this aspen parkland region where we have kind of sporadic to incidental incidences of aspen. Another important context here is the administration of the lands within those two different regions. Most of us are familiar with the green area of the province over there on the far left side. That's typically public land and managed for multiple use. We also have the white area of the province, which is by and large private land, and because of that we have one individual or a small number of individuals making land use decisions on that property. And there's also a fair number of grazing leases, public grazing leases within that area as well. And I think it's important as we work through the changes in the evolutionary history of how we kind of perceive aspen from a livestock production perspective to keep in mind that our land use objectives are very different depending on whether we're talking about public land or private land. On private land, we have this single land use that predominates, agriculture, and in many cases, aspen are incidental to livestock production. And livestock producers are often simply willing to tolerate or put up with whatever aspen happens to be out there. In the case of public land, we have a clear mandate for multiple use, which means co-management of forestry together with livestock production, and that generates the potential for significant conflict. From the perspective of a livestock producer, if you have timber harvesting operations going on within your grazing lease, you might be worried about, for example, is there going to be so much woody debris that my cattle can't get into a significant portion of the lease, which will reduce my allowable carrying capacity and stocking rate? And public lands is going to reduce the number of animals I can have out there. From the perspective of the forester, they're going to see cattle as a potential agent of damage. Damage to regenerating trees, and the potential to reduce the likelihood of regeneration, which in turn could generate future costs, opportunity costs through timber harvesting opportunities, or added cost to reforestation. So there is significant potential here, and that's one of the themes that will come across here as well, towards the latter end of the talk. So in a nutshell, if you take everything that I've got from here on, and you distill it all down, this is, in essence, the story. Attitudes toward trembling aspen have changed markedly. Early on, it was pretty much widely regarded as a weed, which led to certain vegetation control measures. And what I found interesting about this is, although this is very understandable from the rancher's perspective, because ranchers considered it to be a competitor for resources, light, water, nutrients in terms of facilitating forage production in grasslands, foresters also viewed it as a weed early on, because they viewed it as a weed in terms of a competitor with more desirable softwood species like pine and spruce. We have now transitioned away from that towards one of three kind of camps. The middle one is this notion that aspen continues to be treated as a weed responsible for reducing overall grazing opportunities. And that's usually prevalent on private land. Alternatively, there is good research to suggest that there are some really strong benefits from retaining at least a proportion of your land base in aspen. And I'm going to go into, in more detail, some of those benefits. So that's a major selling feature we can make to producers on why they should be co-managing for at least a part of their land base to be kept as aspen. And also on public land, we have this shift towards co-management of joint livestock grazing and commercial forestry. And so, of course, this is a very important area because we have large areas, forest management areas, which also coincide with livestock grazing. And so this has been a really important topic of my research and Art Bailey's research back in the 80s that I think we have some really good data to point out what is the right solution. Okay, going back to the beginning, aspen encroachment. So we have European settlement, we fragment the landscape, we subdivide the landscape, we suppress fire, and this is basically what you get. So this is a comparison of the area occupied in the landscape by aspen. This is Jane Scheffler's work. She did a master's thesis with Art Bailey in the 70s, went back and looked at how much of these are long-term transects that were first established by the surveyors that came through in 1903. Back then, less than 10% of these large landscape level transects were occupied by aspen. The rest was open grassland. By 1963, 60 years later, it was over 50%. That's an absolute increase of nearly 1% a year. Not quite, 0.75%. That's an incredible increase. So you take a landscape that only has small pockets of aspen, 60 years later, it's now over 50%. And there are areas that, although we don't have data on it, at Kinsella, at the University of Alberta Kinsella Ranch, by the late 80s, early 90s, the landscapes were pushing 80 to 90% aspen. So that really brought on the perception that aspen is a critical weed and we need to do something about it. Now, this is also driven in part or complicated by the fact that in some areas we're seeing natural dieback in some of our aspen stands. So for example, this is a healthy aspen stand, and in some areas repeated occurrences of drought in the 80s and especially the 90s and early 2000s, coupled with severe outbreaks of forest tent caterpillars and other stressors, actually caused a lot of these communities to collapse over to what we call decadent stands. Mature trees die, they fall down, and you wind up with a community that's difficult for cattle to actually get into, and in some cases they don't produce a whole lot more in terms of forage production. So in the parkland anyways, we have these very different types of conditions: healthy aspen, and in other cases decadent aspen. Back when I was taking English in high school, my English high school teacher told me there's only three things in life that are certain: taxes, death, and change. This is change. If we look at the historical pollen records from central Alberta, and I realize this is small, but I'll explain what's in here, it really shows that what we've had going on, at least in central Alberta, is a very dynamic process. So this is some bottom lake core sediments that were pulled out, and then they did a pollen profile analysis on these areas. This is the depth of sampling, which goes back to basically 4,000 years. So this down here is 4,000 years BP, this is 1,700 years BP, and here's present. And then they looked at all the different plant species, at least by genus, that they found within those cores. Here's the Gramineae family, so these are grasslands. So areas with lots, or time periods with lots of Gramineae suggests lots of grassland. Here's the populace over here. You can see that the increase in populace is actually occurred relatively recently, going back in that entire 4,000 year retrospective. Okay, so this shift towards more aspen in central Alberta is fairly recent phenomena. And you can also see that if you go back 4,000 years, there was a lot more grassland around back then. And the likely mechanism for that, if you look over here, this is the abundance of charcoal. So what we really had is a highly dynamic system. We had periods of a lot more fire back then, which would have favored more grassland and a whole lot less forest, including the abundance of aspen. So we have to remember that the landscape we have today has always been changing. It will continue to change, and all we're doing is superimposing the influences of our management on top of that. Okay, aspen as an agricultural weed. So Art Bailey spent quite a bit of his early career trying to figure out what's the impact of aspen on the landscape and how do I kill it? How do I get rid of it so that ranchers who didn't want to deal with the impact that it was having on their carrying capacity, that they could find a solution. So that graph over there on the left compares productivity between major habitats. So if you look at the adjacent fescue grassland, we're producing about 2,000 kilograms per hectare, which is a reasonable amount of production. But where you have invasion by aspen, we're losing about 75% of the forage. So if I was a rancher and I now have 50% or more of my landscape occupied by aspen, I would be very concerned, and I'd be trying to figure out how to get rid of that. There's some other issues associated with aspen encroachment, which is the fact that when we get aspen encroachment, we also get soil degradation. We see increasing acidification of the soil, we see a decline in organic matter, the loss of nitrogen, and so on, and that could represent a potential loss of long-term productivity, especially if you're trying to restore these areas at a later date. If you're starting out with lower fertility, that could be an issue. So there's a number of studies that have looked at this process. Okay, so what did Art Bailey do when he started figuring out how do I control aspen? Well, he went through and tested all kinds of different tools. And the tools included things like mechanical clearing, bulldoze it up into windrows, burn it, and then usually seed it down into some kind of a tame forage. He tried different herbicides. These are usually applied through aerial means, fixed wing, aircraft, or helicopter, something like that. Prescribed fire as well. Art Bailey's known as being the firebug, right? He very effectively utilized prescribed fire as a tool to control aspen. And then he even followed that up with the use of prescribed grazing. So using grazing, the actual animal, as the defoliating agent in trying to control aspen, or combining these different approaches. So we'll go through some of the highlights here. So mechanical clearing, very fast and effective, but very expensive. So typical cost of trying to go through this process, not uncommon to hit $400 an acre. Those costs are on the low side. It's probably closer to $500 an acre or more. So that would be more than 1,000, well over 1,000 a hectare if you're looking at doing this. And then you'd have to ask yourself, does the cattle industry and do returns in the cow-calf industry actually pay? And the answer to that might be a resounding no. Now, if we do decide to go through mechanical clearing, we might simply mechanically clear it and then rely on natural recovery of the revegetation. So avoid or bypass the land breaking, field prep, and seeding of tame forage, and that'll save close to a couple $100 an acre. So it's not a bad thing. The only problem is you're going to wind up, you can see this cow over here, you can barely see that cow because there's so many young aspen stands that come up due to the tendency of aspen to sucker, that the producer is then faced with this challenge: how do I prevent this area from immediately reverting back to an aspen forest? In which case they would have just wasted their money doing the clearing and windrowing. So one of the options he looked at was herbicide application. He tried 2,4-D, triclopyr. These are all broadleaf herbicides. And by and large, yes, herbicides do work, but they're very invasive in the environment. This is a comparison of forage yield responses in healthy aspen and decadent aspen. In the case of the healthy aspen, he observed about a 4-fold increase in productivity, which is pretty good return on investment. In the case of the decadent aspen, it was about a 10-fold increase in productivity. So yes, you can use herbicides as one of the mechanisms or one of the tools in order to increase carrying capacity. Prescribed fire is another one that Art Bailey spent many decades, well, at least 2 decades, right, exploring different options to control aspen. The benefit of fire is that it's low cost, typically under $10 an acre. The big problem is there's not many people with the expertise able to do this. Art, and more recently Barry Irving, were 2 of the only individuals that were left doing commercial prescribed burning in Alberta in the last 20 years that I know of. And the reason for that is because it's a very risky endeavor. It's difficult to actually get the liability insurance to be able to do this. So unfortunately, this is one of the best options for aspen control for the environment in terms of cost. Not a lot of people are willing to do this. Okay, there are some other limitations in terms of the use of prescribed fire. You usually have a very narrow burning window. So aspen forests are known as asbestos forests, which means they don't burn very effectively in the summertime because they have high humidity, they're very green, lots of lush understory. The consequence is you have often a week or less, sometimes just days to burn in the spring. It's a very small burning window. And extended snow cover can further restrict that and limit the effectiveness across the entire landscape. And this is a typical scenario. What you do get if you do burn, aspen's very tolerant to fire, very adept at suckering, so you get this massive flush, and then you got to figure out, what do I do to control all that regrowth, or it's going to go right back to forest. So one of the tools that has been developed and is shown to be very effective is using what's called mob grazing or management intensive grazing in order to control aspen regrowth. So this is Lee Arthur's work. Lee did his master's in the early 80s. He looked at either June grazing, so that's a mid-growing season treatment grazing, or late season grazing in October at different stocking rates, light or heavy, and then looked at how much mortality the cattle under this controlled grazing system would actually impose on the aspen stems themselves. And actually, the technique is very effective with much greater mortality if you graze early in the growing season. This is largely because cattle are more likely to defoliate and damage the stems before they've undergone lignification. And you can see the important role of stocking rate. A higher stocking rate forces animals to utilize more of that aspen. This fence line comparison over here shows the heavy June and the heavy October. So this red bar coincides with this treatment, and this bar coincides with this treatment. So timing and stocking rate are 2 critical components to using grazing effectively. Okay, this has been further refined by Mike Alexander in his work, where he looked separately at healthy stands. So this graph is for healthy stands, and this is decadent stands. So he looked at what stocking rates are actually needed to create that shift, so knock back the aspen and to restore herbage productivity. His conclusion was that if you want to knock aspen down in healthy stands, you really need a heavy stocking rate. Because it's a healthy community, you get so much flush of aspen, it takes that very high stocking rate in order to deal with that aversive effect that aspen typically have on cattle. It takes a high stocking rate, forces them in, forces them to use that aspen, forces them to trample it down and damage it. In contrast, within these decadent systems, you can get away with a much lower, a more conservative stocking rate. This is actually a good thing, the use of a moderate stocking rate, because if you're trying to conserve the adjacent fescue grasslands, fescue happens to be quite susceptible to heavy grazing. So this is a more desirable treatment if you can get away with it. Okay, the best solution is really to combine these different management practices. And one of the obvious ones is to use fire, followed up immediately with grazing. Fire controls the canopy, the mature trees, initiates that flush of regrowth, and then you go in and you use cattle to control the suckers as they come up. This is the sequential changes in use of woody forage that you would expect to see following burning. So you can see this is woody utilization in percent. The unburned, you're getting only about 10%. This is voluntary use by cattle. They use it a little bit, but not a whole lot. Immediately after fire, those plants are actually quite desirable. Young saplings are pretty good forage, and cattle are willing to utilize them. So utilization rates are well over 40% here. If you wait 2 years after fire, the palatability drops markedly, and your utilization drops. So timing is everything after the fire. You have to get in there right away. And if you do that, and you do it not only in the first year, but you continue that process of hitting those stands of regenerating aspen over time, you can have a marked impact on the population. So this is aspen stem density, 4 years of data, early June grazing treatment. You can see we're going from upwards of 20 stems per square meter all the way down after 5 years to close to 0. So we've actually gotten biological control of those trees. We've managed to completely turn that community around. Here's the late August, September treatment, and again, you see a similar response in that particular case. Now, it's a little bit surprising that we're getting a better response with the late season grazing treatment. Fitzgerald, who was a PhD student with Art Bailey, attributed this to the incidence of frost and felt that the combined incidence of grazing with frost stress at the same time resulted in that accelerated mortality. Okay, I wanted to make one other point here before I leave this, because there's a number of papers that have come out, Campbell and other authors, that have proposed that really a big part of the expansion of aspen here in central Alberta is being driven by the fact that we've replaced the historical ungulate gill, things like elk and moose and bison and so on, particularly bison. Even though bison are largely a grazer, they felt that the impact that bison had on the aspen population was actually quite significant. And by removing bison and replacing that herbivore with cattle here in central Alberta, we may have augmented or facilitated greater aspen expansion. And so a few years ago, Bob Hudson and a number of us worked on a project looking at multi-species grazing down at Kinsella. And some of this work was recently published. This is a comparison of cattle grazing with a mix of native ungulates. The native ungulates are bison, elk, and deer together. And there's 3 types of data on here. One is the defoliation data. The second one is the physical damage. So physical damage, things like leader breakage, stem breakage, vertical displacement, basal scarring, anything that could actually affect the outcome of that sapling surviving and regenerating into the mature stand. What we found was quite interesting, that most of the defoliation was not done by cattle. It's actually done by wildlife, which kind of makes sense because these herbivores are largely browsers. And it was largely elk, not surprisingly. But that defoliation didn't actually translate into a lot of mortality. So the mortality was actually lower within the native mix, sapling mortality. There was more mortality within the cattle treatment, which tended to be associated with physical damage itself. Okay, leader breakage, basal scarring, and things like that. So again, it reinforces that cattle can actually be quite an effective biological control agent. And I would argue, based on this, at least as effective as the native herbivores that we had out there prior to European settlement. Okay, where do aspen forests fit in to our contemporary cow-calf production systems? Do they have any benefit to producers? Now, I would argue they do, and I'm not going to go through all the benefits, but I'm going to touch on at least a few of the highlights. So if you have a parkland environment, for example, with 20% of the landscape consisting of aspen, those aspen trees provide very strong benefits. Things like shade in the summertime, protection from cold winter winds during the winter months, and so on. And so the thermal benefits alone are quite significant to an individual cow-calf producer. cover for young calves, and so on. The same applies to shrublands as well. In addition, we've got benefits for wildlife and so on. But one of the neatest benefits that I actually came across is this little response right here. During a drought year within the Aspen parkland, cattle actually shift their use patterns and spend a lot more time foraging within the forest. So 70% of their time in the drought year, they basically occupied the forested environments. In contrast, during a normal year, it was about 50-50. This shift we attributed to the fact that grasslands had basically dried off, their productivity declined, their quality declined, and so what they were doing, they were utilizing the understory of these forested areas, which tend to provide forage when the grasslands have disappeared, been utilized. Now, when Art Bailey published this back in 1972, he didn't have a really good explanation for why this happened. I had a PhD student, George Powell, that did some subsequent work about 10 years ago. And what we actually found is that the understory of the aspen forest had much higher relative humidity. So during a dry year, it allows those plants to continue to photosynthesize and continue to maintain active growth. So you basically have an oasis of extended green phenology underneath the aspen stands. This is a really important benefit during a drought year. So that it's an emergency reserve supply of forage. Very valuable if you happen to be in an area that's drought prone, and we're all drought prone in this province. Okay, another interesting thing is if you look at the overall profitability or the potential to earn revenue from, let's say, a clear and break situation where we get rid of all of the trees in the landscape, clear them all, replace it all with tame forage. Remember, it comes at a very high cost, high mechanical cost, and so on. We've lost the trees within that system. If you compare that to a low-cost spray and burn situation where we're going to spray the overstory, burn it, then maybe use grazing as a strategic control tool for the aspen regrowth, the potential to earn revenue on this, and this is a graph of net present value, so it looks at the total cost, the total revenue stream generation potential. The total net present value is actually higher in the spray and burn. And a big reason for that is because of the inclusion of this browse component. Now, if a producer says, well, my cows can't eat browse, or they don't want to eat browse, I'd say BS, because we have great data that shows browse is very high quality in many of our aspen stands, right? And I see Donna nodding her head over there going, yes. Donna specializes in boreal forest grazing, and so is very, very familiar with this. And so really, it's a matter of making sure that we fully recognize and value the contribution of the understory of those aspen stands. They're very, very valuable. Okay, aspen cattle integration on public land. So this is kind of the third phase. Looking at, on public land where we have multiple use mandate, how do we work these two land uses together really effectively? So I'm going to talk quite a bit about Jill Kaufman's work. She completed her master's work in 2011. She's published 2 papers already. Another one is under revision, and there's a 4th one that's going to be submitted as well. So if you're a master's student, you're thinking, wow, 4 papers, go for it. In this particular study, this was done in the Drayton Valley area, and it involved deciduous forested areas. So she had a number of experimental paddocks. Each one of those paddocks consisted of clear cuts, uncut forest, partial harvest, and skid road. Then she looked at cattle use patterns, the impacts on the aspen regeneration, and on all the factors associated with utilization across the cut block that may have influenced cattle use patterns. Okay, so this is the electivity results. These are the preferences or avoidances that cattle exhibited for different habitats. We anticipated, if the foresters were correct, we thought, well, cattle are going to move in the clear cuts. They're going to want to utilize those open areas that have now been created by logging. Did that happen? No, it didn't. Cattle actually had the highest preference for uncut forest, to our surprise. So we're looking at this, scratching our head, going, why would they do that? And moreover, they actually avoided the clear cuts. So here's a clear cut over here. This is the avoidance. And the B indicates that it's significantly different from 0. So completely counter to what we had initially hypothesized. We thought, well, they're going to prefer the clear cuts, and that's going to create potential for conflict. Not necessarily the case. They also avoided skid roads. So I want to dig into this in more detail because we have some really good data to try to explain why cattle behaved the way they did. If you look at the total forage supply among those habitats, we see a pattern that we would have expected. The clear cuts produced more. You remove the overstory, creates opportunities for regrowth, and so the total availability of forage is actually higher in both clear cuts and partial harvested areas, and even skid roads. The uncut areas had the lowest productivity. So it's not really forage productivity that's driving animal behavior here. Something else is accounting for where those cattle wanted to spend their time and why. Okay, we also did a more detailed analysis where we looked at individual patch level selection by these cattle when they were free-range grazing within these paddocks. And as we expected, we saw a positive relationship between use at the patch level and biomass and quality. Forage protein. Makes sense. Animals try to optimize their diet. The way they do that, to increase intake, they select for areas with more biomass, and they select for areas with higher quality, right? Do you want to go for the low sugar or the high sugar muffin? I want the high sugar muffin, right? Do you want to go to the table with 5 muffins or with half a muffin? I'm going to the table with 5 muffins. So that's exactly what they're doing. This is consistent with every other response that we would expect out of cattle. But when we look at the other factors, those that are negatively associated with cattle use at the patch level, the water distance was expected because cattle are lazy. They hang around near water. The further away you are from water, the less likely they are to utilize that patch. But the slash, the impact of residual logging debris, and the impact of sapling density, the negative impact that those two factors had was quite marked within this system. So cattle are really trying to pick the path of least resistance when they're foraging. And in some cases, slash cover and sapling density represented significant obstacles. So we're going to look at these in a little bit more detail. So one way that we looked at logging debris is we looked at the relationship between maximum slash height and distance to the nearest grazed patch. So within our regen plots, we figured out what's the maximum height within there, and then we looked for any evidence of cattle use after the cattle had left that paddock. And we measured that, and we found this relationship, which again reinforces the notion that debris can serve as an effective barrier for cattle access, entry, and subsequent foraging. Now, if you're a livestock producer, you might be concerned about this. If you're a forester, you're probably happy about this because you're going, good, we can use slash as a tool to minimize cattle occupancy in cut blocks, right? So it can be looked at from either perspective here. We also measured what's called sapling impedance, which is basically a rating system that represents how unlikely is it for an animal to get access into a specific patch based on the abundance or density of saplings within there. Dog hair aspen in particular can be so thick that it's very difficult for an animal to actually enter into those areas. And at some point, they just give up, right? You turn that way, there's 20 stems. You turn this way, there's 3 stems. You're going to where there's 3 stems, especially when you're a large animal with 4 legs. And so sapling impedance was clearly higher within the clear-cut area, and it's largely associated with the fact that that's where we saw the highest stem densities. And I have that data for you too in a moment. So there's the aspen densities, as you would expect. Very, very high in the clear cut, moderate in the partial cut, the uncut fairly low. The skid road was also quite low. Now the skid road result did not surprise us too much, and we attributed this in all likelihood to soil compaction. Skid roads are where they basically, after they've cut the trees, they drag them out to the road. And so that compaction is fairly well known to have a negative impact on the ability of aspen to regenerate from underground root systems. So just to kind of close this loop, here's our electivities again. Remember, these animals preferred the uncut forest. They avoided the clear cut. And the mechanism for that is really the combination of slash coupled with the fact that we have this high sapling density, which creates a barrier, really, to animals moving into there and utilizing the forage within those patches. That's despite the fact that those are the most productive areas of the cut block. Okay, we also quantified total aspen damage. Again, from a forestry perspective, we want to know how much impact was there. As you would expect, there was actually very little damage within the clear cuts. Around 2%, just over 2% of the stems were damaged. The highest damage was actually in the uncut forest, but remember, these are relative, so these are proportional measures. Because we didn't have a lot of stems in the uncut forest to begin with, this represents a lot of stems relative to what's in there, because these are proportional data. Most importantly, if we looked at the damage from the perspective of stalking rate, because we also tested low and high stalking rates within these systems, stalking rate consistently increased damage. So the high damage, we had about 7.3% of all stems affected. At low stalking, 2.3% damage. So the golden rule, if you talk to any range manager, is that stalking rate is the single most important variable that determines whether your management system is sustainable. And this supports that again. Low stalking rate, very compatible. High stalking rate, be careful. Now, I will tell you, the low stalking rate we tested here is the stalking rate recommended for public land in Alberta. That is the low stalking rate, okay? So this is actually a very good scenario. The high stalking rate is a worst case scenario, assuming we have a grazer out there that may not be paying attention, pardon me, to the actual guidelines that are in place. We also looked at the aspen height growth. You can see the clear cut and the partial cuts are both doing very well, and the reduced growth on the skid roads, again, we attributed that to soil compaction. We don't have specific data on it, but this is consistent with what Cam Lane and others have found in their master's work within areas undergoing logging and forestry, grazing at the same time. So if we put this all together, what time do we have? 10 minutes. Oh, no problem. I have like 4 slides left. Okay, so if we put this all together into a management system, and we look at how would we integrate this if we have, let's say, a grazing lease situated in the boreal forest. So what we might decide to do, this is our grazing lease, and we want to put in a cut block over here. The first thing we might do is subdivide it into 2 different pastures. We put the cut block over there on the left side, and immediately we know this area is going to be susceptible, right, to potential damage, particularly early in the growing season. Because we know that from the work that Art Bailey did and his students at Kinsella, where that June grazing period very, very sensitive in terms of the impact that we might see on aspen regeneration. So if we're going to put the cut block over here, spend our time early season grazing over here, let's let this regenerate as much as we can, and either don't graze it at all the first year, or if you have to graze it really late in the year. And of course, use the right stalking rate at all times. And then later on, 2 years later or 5 years later, we might decide to come in and put a cut block over here. We flip that around, early season grazing on the left side, and come into this area late that year, or even wait if we can till the following year to allow those aspen stems to get as tall as possible, as lignified as possible, so they're less likely to be either consumed or broken. And so using this process, very simple management exercise, but it would allow forestry and cattle grazing to coexist quite nicely. So closing thoughts. So this is trying to kind of mush everything together into some synthesis points. So where we consider aspen to be a weed, we really can get fairly effective control. Mechanically, if we have to, that wouldn't be my recommendation. It would be using fire, maybe herbicides to kickstart the process of opening up the canopy and increasing the fuel in the understory. And ultimately, even after you burn, bringing in prescribed grazing in order to control that regeneration. And you have to do it very quickly, early on in the season, in order to make sure that you overcome that avoidance that will come later on in the year or the following year. Aspen reestablishment can be achieved by modifying grazing practices using the information we learned up here by simply flipping it around. If you want grazing to regenerate, like you would in the boreal zone on public land, simply defer grazing, light stocking rates, give the aspen a chance to get mature enough that they're going to be avoided. In general, I think we have a really good framework that if we put all of this information together, there's an excellent basis here for the foresters and livestock grazers to be able to coexist, which is pretty important considering there's well over 5,000 grazing leases in the province. 6,000, and a lot of those, I don't know how many of them, but a lot of them are in the boreal region, and they impact that joint use between forestry and livestock production. So I think there's a good framework here. It assumes, though, that the willingness is there on behalf of both the foresters and the livestock industry. And aspen forests can be an important resource in and of themselves, particularly on public land, as I said earlier, for things such as providing that emergency forage during times of drought. Really important, beneficial component of these areas that should not be underestimated. So there's a lot of research I summarized here. If you want a copy of it, I'm happy to send you a PDF of it. A lot of the research that I discussed here was Art Bailey's work that I kind of gathered up and synthesized. Barry Irving also provided me with some great information and has been involved in a lot of the work that Art Bailey did over the years. And there's at least 8 or 10 different grad students' work that I synthesized in this whole process. So thank you for the invite, and I'm happy to take any questions or hear any comments.